Today we shall talk about ballistics part 4. There are three types of ballistics which are called internal ballistic, external ballistics and terminal ballistics. The external ballistic starts where internal ballistic ends and before the terminal ballistic start. The external ballistics has become very important for several reasons, especially for India. One of the reasons is the space travel and the other is illegal manufactured firearms which are plenty in use for the purpose of making suicides oblique homicides, and these have no specifications with them. Hence the external ballistics has become very important for our country. The external ballistics has a certain range which cannot be determined by any accurate method. However, at an angle of elevation of 29 degrees, the maximum range is attained, and between 29 to 35 degrees, the range cannot be accurately determined by any means due to variation of several factors. To give the example, the air will change, not only it will block the projectile or projectiles, but will change the spin also of the bullet. Similarly, we can have the effect of resistance of air, which will blow the projectile in the direction of its wind. The direction will push the bullet in the direction from which it is coming. Similarly, the alteration will take place in the trajectory of the bullet also. The trajectory of the bullet is maximum at a certain angle whose accuracy cannot be ascertained in advance because of the variation in various factors. However, if the angle of elevation is appropriate, there is a region which can be called safe region, and people in that region will not get hit by the bullet, and that is termed as a safe region in the trajectory. The other point which I wish to tell you is that overstabilization of bullet, which is called yaw, also gives a instability to the bullet when it comes out of the muzzle end, and this is called yaw.
Dear students, after studying this module, you shall be able to know about yaw and stability of bullet, identify the effects of projectile on bullet trajectory, and learn about the firing angle. Now, let us start this chapter with a brief introduction. External ballistics has assumed great importance because of its application, especially in space travel. It has tremendous use in India, where criminals for the commission of crime, murder, or homicide and other crimes are using a large number of illegal homemade guns. External ballistic starts where the internal ballistics end. Internal ballistics make study of what happens inside the barrel of the gun till the projectiles bullets leave the muzzle, where external ballistic is involved in the spread of pellets in a shotgun, trajectories of bullets, etc. Many people believe that bullets fly in a straight line. This is untrue. They actually travel in a parabolic trajectory, or one that becomes more and more curved as range increases and velocity drops off. The bullet actually starts to drop when it leaves the firearm's muzzle. However, the center line of the bore is angled slightly upward in relation to the line of the sights, so that the projectile crosses the line of sight on its up way and again on its way down at what is called the zero range. Zero range is the farthest distance at which the line of sight and the bullet's path intersect. Now, dear students, let me tell you about angle of firing. The angle of fire is the angle at which the barrel axis lines with the base line. When the angle of elevation or firing is 1 minute, then the line of fire and baseline will get apart by a distance of over 1 millimeter at 4 meters and about 30 centimeters at 1000 meters. The angle of elevation is generally low, especially in cases of hunting purposes. These angles can have lower values, and this also holds good for normal cases as well. However, if the target animal is at higher point, the position may be different. With small arm bullet, maximum range is attained at an elevation of about 29 degree. From 29 degree to 35 degree, there is a little increase in range. The angle of elevation at which maximum range is attained is called as the critical angle. There is no accurate way of determining the maximum range of a bullet. The use of ballistic table or ballistic software based on the CEC or MAVE-3 G1 drag model is considered the most appropriate method for general use. There is an additional modern alternative also available, presented by Professor Arthur J. Pesa in 1991. When the firing is at an angle, the elevation may give rise to an area which may be called a safe zone along the trajectory, because the projectile will be moving over the heads of the person standing along the baseline. If a .303 rifle is fired when the sights are set to a target range of less than 300 meters, there would be practically no safe zone throughout the entire range. At greater ranges, however, there will be a safe zone. Safe zones are determined with the help of a graph. The height of the trajectory at various distances for the given elevation are plotted against the distance. The absolutely safe zone for the given elevation is the portion of the trajectory where the height is over and above the height of the target, 2 meters from the ground in the case of human target. There is no difficulty in finding the safety zone limits, and exercise of finding them is quite easy. The trajectory of a projectile, in this case a rifle bullet, is the actual path that the projectile follows after leaving the muzzle. Now let us discuss yaw and stability in detail. Bullets do not typically follow a straight line to the target. Rotational forces are in effect that keep the bullet off a straight axis of flight. Yaw is something which only has relevance to rifle ammunition. This is due to slight destabilization of the bullet as it leaves the barrel, and is probably the result of excessive spin on the bullet. This causes the bullet to describe an air spiral while at the same line having a spin around its own tail axis. Thus, yaw refers to the rotation of the nose of the bullet away from the line of flight. At close ranges, this results in large target group than would be expected. As the range becomes greater, the effect disappears. and the target groups return to their normal expected dimensions. The effect is very similar to the spinning top, which wobbles slightly before settling down into a stable spinning condition. In other words, yaw is over stabilization of the bullet as it leaves the muzzle, resulting in the bullet describing an air spiral which at the same time spins round its own tail axis. As the bullet flies, the principal aerodynamic force on the bullet acts directly opposite to the velocity vector. The projection of this force along the longitudinal axis is the drag force on the bullet. The drag force acts through both the center of pressure and the center of mass, and so it does not create a torque on the bullet. With the tiny yaw angle, a very small component of the aerodynamic force acts horizontally and sideward on the bullet. This small side force, acting at the center of pressure, creates a torque on the bullet equal to the force multiplied by the moment arm, that is, the distance between the center of mass and the center of pressure. The direction of this torque is downward for a right hand spinning bullet or upward for a left hand spinning bullet. Now let us have a look on effect of projectile on trajectory. Trajectory of a projectile gets affected with the shape of the bullet because different shape of bullet face different air resistance. Some overcome air resistance better than others. A projectile suffers setback to its movement from many factors. Some of them are the resistance from the head, the base drag, and the skin friction. So far as the skin resistance is concerned, it occurs due to the interaction of air and the metal molecule, but its magnitude is very small and is to be considered negligible. As far as base drag is concerned, it results from the backward sucking of the projectile due to vacuum created by it when it moves forward. The forward movement of the bullet creates vacuum and hence a base drag. When the projectile is given a shape as boat tail, the base drag gets considerably reduced. The head resistance is the most significant of all the factors. The head resistance force is a force which acts on a moving body or projectile. Since this retarding force depends on the head area, called as the projection area, that becomes more when head area is more and less when the head area is less. As head resistance is directly proportional to the projection area or head area, it has resulted in great popularity of users. These are called Spitzer's bullet. To measure the efficiency of the shape of a bullet so as to overcome air resistance, it is done in terms of form factor or coefficient of reduction, which can be determined experimentally by comparing the retardation of the projectile under investigation with standard projectile or utilizing other methods. Apart from shape, there is another important factor requiring consideration, and that is uniformity of the projectile structure. It is therefore absolutely essential that center of shape must coincide with the center of gravity to avoid oscillation of the bullet during the flight as well as irregular trajectories. If this condition is not met, the trajectory will become irregular and will strike at a point away from the defined point on the target. Non-uniformity can result due to non-uniformity of jacket of the bullet or improper molding of the lead case or presence of bubbles in the projectile. The air resistance will affect the trajectory of a bullet or projectile by reducing its velocity and by pushing it in the direction it is blowing. The resistance of air depends on its density as well as temperature. Thinner the air, the lesser will be the air resistance. Higher temperatures of atmosphere tend to decrease the air resistance. Fortunately, the drag force on a bullet, which is by far the largest force, acts through the center of mass when the bullet is well stabilized and thus creates no torque on the bullet. If this were not true, the bullet would lose stabilization and tumble erratically in flight. Dear student, now let us discuss drift. Drift is caused by the action of wind that not only tries to hold the bullet back but alters the direction of the spin. Gyroscopic drift, therefore, may be defined as the gradual deviation of a bullet from its intended path due to its spinning motion imparted by the rifling of the barrel. A bullet fired by a rifled weapon having rifling to the right has the tendency or drift to the right, and left handed rifling will result in left handed drift. Drift becomes very pronounced at long ranges. The drift of a .0306 bullet at a range of 2000 yards has been found to be 12.5 feet. At short ranges, drift is very small. It is about 1 foot for the same bullet at 1000 yards. It may be interesting to note that most rifles have some lateral jump during firing, whose estimation is quite difficult. Now, students, let us summarize this chapter. So, in this chapter, we have learned that drift is caused by the action of wind that not only tries to hold the bullet back but also alters the direction of the spin. Then we have come to know that yaw is the overstabilization of the bullet as it leaves the muzzle, resulting in the bullet describing an air spiral whilst at the same time having a spin round its own tail axis. The angle of fire is the angle at which the barrel axis line with the base line. Thirdly, in this chapter, we have come to know that the air resistance will affect the trajectory of a bullet or projectile by reducing its velocity and by pushing it in the direction it is blowing. Fourthly, we have learned that when the firing is at an angle, the elevation may give rise to an area which may be called as safe zone along the trajectory. Then we have come to know that bullet path is a term used to denote the perpendicular distance between a point on the line of sight and the corresponding point on the bullet trajectory at any range distance from the muzzle. And lastly, we have learned that it is very important to understand that bullet path is measured perpendicular to the line of sight regardless of whether the barrel of the gun is level or tilted upward or downward.